Today, we're going to learn about factors and prime factorization. But first, let's focus on factors and multiples. Can you read the title of this page for me?
It says, Factors and Multiples.
That's right. Let's start with the first point. It says factors are numbers we can multiply to get another number. Can you explain this in your own words?
I think it means factors are numbers that, when multiplied together, make another number. Like 2 and 3 make 6.
Exactly. If we write it as a math expression, we can say 2 times 3 equals 6. Now, look at the second point. What does it say about multiples?
It says multiples are results of a number multiplied by an integer.
Correct. So if we take the number 6, and multiply it by different integers like 1, 2, 3, and so on, we get multiples. 6 times 1 equals 6, 6 times 2 equals 12, 6 times 3 equals 18, and so on. Do you see how multiples are generated?
Yes, you just keep multiplying the number by 1, 2, 3, and so on.
That's absolutely correct. Now, the example on this page mentions the number 6. Let's review the factors of 6. Can you list them for me?
The factors are 2 and 3 because 2 times 3 equals 6.
Well done. What about multiples of 6? What does the page say?
It says 6 is a multiple of 2 and 3 because 2 times 3 equals 6.
Perfect. So, to summarize, factors are the numbers you multiply to get a product, and multiples are what you get when you multiply a number by integers. Do you have any questions?
No, I think I understand. But how do we find factors for really big numbers?
Great question. To find factors of big numbers, you can test smaller numbers to see if they divide the big number evenly. For example, to find factors of 24, you check if 1, 2, 3, 4, and so on divide into 24 without leaving a remainder. We'll practice this more later. Now let's talk about factoring. Let's start with the definition. Do you see the first point under the heading factoring?
Yes, it says, factoring is finding the factors of a number. What does factors mean?
Good question. A factor of a number is any number that divides it exactly, without leaving a remainder. For example, 2 is a factor of 6 because 6 divided by 2 equals 3, and there's no remainder.
Oh, so factors are like numbers that fit evenly into another number.
Exactly. Now, look at the second point. It says, example, factors of 54 are 9, 6, 3, and 2. Can you explain why 9 is a factor of 54?
Let me think. Is it because 54 divided by 9 equals 6 without any remainder?
That's correct. 9 is a factor because 54 divided by 9 equals 6, and 6 is also a factor of 54. Can you find another factor of 54?
I think 3 is a factor too, because 54 divided by 3 equals 18.
Excellent. You're getting the hang of this. Remember, factors always come in pairs. For example, for 54, one pair is 9 times 6, and another is 3 times 18.
Oh, so for each factor, there's another number it multiplies with to make the original number.
Exactly. Well done. That's how we find factors by checking which numbers divide the original number evenly. Now let's learn about prime numbers. Let's start by reading the heading on this page. Can you tell me what it says?
It says, prime numbers, in big bold letters.
That's correct. Now, look at the first point under the heading. What does it tell us about prime numbers?
It says a prime number is divisible only by 1 and itself.
Great. So, if I give you a number, like 5, Can you tell me if it's a prime number and why?
Yes, 5 is a prime number because it can only be divided by 1 and 5 without leaving a remainder.
Excellent. Now, let's move to the second point. What does it say about prime numbers?
It says that prime numbers must be greater than 1.
That's right. So, can 1 be a prime number?
No, because it's not greater than 1.
Perfect. Finally, look at the third point. Can you list some examples of prime numbers mentioned there?
Sure, the examples are 3, 7, 11, 17, and 23.
Well done. Those are all prime numbers. Now, do you have any questions about prime numbers?
I think I understand, but how do we find larger prime numbers?
Good question. There are methods like checking divisibility by smaller numbers. We'll explore those methods in another lesson. For now, you've done a fantastic job. Now let's move on to learn about prime factorization. Can you read the first point under the heading Prime Factorization?
It says, find prime factors of an integer. What does prime factors mean?
Great question. A prime factor is a factor of a number that is also a prime number. For example, 2, 3, 5, and 7 are prime numbers because they have only two factors, 1 and themselves.
So, to find the prime factors of a number, we break it into smaller numbers that are all prime.
Exactly. Let's look at the example in the second point. It's about finding the prime factors of 891. What does it say to start with?
It says, start with the smallest prime number, 2, but it also says that 891 is odd, so it's not divisible by 2.
Correct. If a number is odd, we skip 2 and move to the next prime, which is 3. Do you see what happens next?
Yes, it says 891 is divisible by 3, so we divide. 891 divided by 3 equals 297.
Right. And then we keep dividing by 3 as long as it works. Can you continue from there?
Sure, next, 297 divided by 3 equals 99, then 99 divided by 3 equals 33, and then 33 divided by 3 equals 11. But 11 is prime, so we